Hello, and welcome to Mind Over Megabytes. Welcome to the number one lecture of Cisco Packet Tracer tutorial. So, today we are going to start with one of the questions related to Cisco Packet Tracer. So, the first question is saying that design and configure the network given in the figure given below. Check the connectivity by ping command. Also, describe the functionality of devices in given scenario. Show the packet header format of ARP in Cisco Packet Tracer. So this is a given scenario where we have to find the connectivity and describe its functionality. So I have already created this scenario in the Cisco Packet Tracer application. This is the total model. So first of all, we need to describe the functionality. The server is basically a central device acting as a file storage uh, that is a file storage area for different end devices, which is connected through two switches. Basically, these two switches are enabling these end devices to be able to connect to the server. So server is basically configured using in the config tab. We need to go through the fast Ethernet in order to assign the IPs to these four different end devices. So what we are going to do is create a server pooling using these following steps. So first we need to go to the config tab, then interface fast Ethernet 0 and assign it uh, basically any class C IP address where these three octets belongs to the network bits and the last octet belongs to the host bit, which we can assign the IPs to different end devices. So the three octets will not change, only the last one will be able to allow create a network. So after assigning this, we will go to the services tab. Then from the services, buttons, we need to access the DHCP service and we need to turn on that service of the DHCP. So after going to the service sys DHCP, we need to create a server one named pool where we have to assign IPs starting from the host bit 81, as 80 is already assigned to the server statically. We cannot assign these to the end devices that are these PCs and laptops. So we need to configure it from 81 onwards. I have also limited the number of users to 10 so that only 10 number of devices can be assigned different IPs from these set of IPs. Let's close this. This is the proper setup that we can use to communicate and send data packets to one another. Let's uh, check a simulation and check out the ARP header format of these data simulation. We want to click the data simulation on the right hand corner, then select the message icon from the top menu. We will, for example, convert this PC0 to PC2 and simulate the message of the uh, message passing from PC0 to PC2. Let's simulate this. You can see the message is being transferred to the switch from the different devices. These two have rejected the request. Only the switch 2 has taken the request. Now, what will switch 2 do? It will pass on the data packet to these PC2. See, switch 1 has passed on the request successfully. Now, this simulating. There is some sort of error. Let's retry this. Let's now send from PC1 to PC2. See, now the packet has been successfully sent out. This is the last status that has been updated. That is successful. So now we want to see the ARP header format. So we want to check out this. This is the ARP header format, Ethernet to header. Now, if we want to ping uh, the IP address, that means we want to connect or check if the PC1 is or PC2 is working. We need to check ping the IPs of these, uh, ping the IPs of these computers. Let's ping the IP, that is ping 192.168.40.2. See, there is reply, and we have sent 4 packets and receive 4 packets. That means the IP of this PC1 is working perfectly. So now moving on to task 4. Consider the following figure. The PC is connected to the console part of the switch. All the other connections are made through fast Ethernet links. Which types of UTP cables can be used with segment 1, 2, and 3? This is a given scenario where we have to identify which type of wire we need to use between these end devices or switches and routers. So the first segment we need to find out, as it is an end device and a switch. So we can see here that it is an end device and this is a switch. That means we need to use a straight through wire because the PC and then switch is a different type of devices. So straight through wires are used for different types of devices. So switch. So between switch and router, what type of wire we can use? We can use a straight through wire because switch and router is also a different type of device. We can say that it is a same of type of device as both are networking devices, but the functionality of switch and router differ significantly, as switch is an intelligent device and router is used for routing only. The router is of the same type, so we are using copper crossover wires to match the match the type of devices, we need to use these copper crossover wires. Now, looking at the question number 5, which we have here, create a network using a packet tracer having 8 PC with 4 of them in one broadcast domain and remaining 4 in other broadcast domain achieved by using hub and bridge. Show steps in form of screenshots. Also explain the working of the bridge. So I have created this scenario over here. Basically, it is asking us to create 2 broadcast domains, means a hub is used to broadcast all the devices in one network, and there is another network that is also connected using the hub, which is basically a broadcast domain where all the PCs are getting the same information, regardless of whether the data is sent to PC 12 or PC 9 or whatever. So these two are different types of networks that are connected using the bridge networking device, which helps to uh, send data over different group of networks. So the server one has been configured to allow server pooling between these 4 devices, and server 2 has been configured to provide IPs, pools of IPs to these 4 different devices. So if we want to simulate and send the data between the PC5, let's say PC5, select data passing the data from the PC5 and the PC9, and then simulate this. So what is basically happening? The broadcast domain, the hub, is sending data to all of its devices. They are rejecting it because it is not intended towards them. So Bridge has also passed the data to all the broadcast domains in this hub network, as it was intended to be sent over there. It is uh, all the other devices are rejected by these other devices. The message has failed because of this. Different networks have different IPs, so the IPs assigned to this simulation is having different set of network over here, as the network bits is starting from 80 and the server one is starting from 40.